Lesson 3.6, using perpendicular and parallel lines. A construction is a geometric drawing made with what two items? These go back to ancient times, so they're called a compass, which looks something like this. There's a pointy tip here and a pencil here. It makes circles and arcs. And a straight edge. A lot of people say ruler. It's actually a straight edge. Use the compass to measure things. You've often seen that in the movies where they are marching across a map, measuring distances using a compass. So how do we do constructions in this day and age? Well, we use computers. So if we want to make a circle, we would do it with a point and another point on the circle. And if we wanted to make a line, we would just connect the dots, and so on and so on. So if we want to construct an arc, we would just select the 3 points, have it construct a arc. You can also have it create a parallel line through a point. You can also have it create a perpendicular line through a point. It's called Geometry Sketchpad. It's quite handy. A lot of fun to play with. So the answer to the question is we use our computers. Engineers use lots of different computers. The original one, oh, I cannot remember it right now, but one of the latest ones is a MicroStation product. So there's lots of different products out there. So this is a few postulates that are really, really straightforward. If these two lines are parallel, and these two lines are parallel, so L's parallel to M, M's parallel to N, L is also parallel to N. This is the transitive property. A then B, B then C, A then C. Very easy stuff. Perpendicular also fairly easy. Not quite as obvious, but pretty easy. If these two lines are parallel, draw that in red so you can see it. And this is perpendicular, and this is also perpendicular. If one, then the other. And I have jumped the gun. This actually goes down here. And the original postulate, you don't need to worry about. Right. Original postulate just says if there's a point not on a line, there's one and only line that goes through that's parallel. I call that duh. I'll actually keep this. All this goes down there. And I've also jumped the gun on this one. I'm going to cut and paste it. It belongs down here. Right there. And this postulate up here just says line on a point, one and only one line, that's perpendicular. Again, I call that a duh theorem, postulate. So this one's kind of silly. Like I said, it's very easy. This is A and it's parallel to B, and B is parallel to C, and And we get L all the way down here. A is parallel to B, and B is parallel to C. Eventually, we'll say by transitive, A is parallel to L. This is really nothing new, just kind of putting together lots of data. It's a problem for you to try. You can do it lots of different ways. If you have some perpendicular lines, that would make these lines parallel, but we don't really care. We got a 180-degree angle here. 2x plus 2 equals 90. 2x equals 88. X equals 44. That's it. So we won't call this the most worthless lesson I've ever done, but it's in the top 10. Parallel lines, perpendicular lines. If you have two lines that are parallel to each other, then any line parallel to them is also parallel to each line. And two lines that are perpendicular to the same line are parallel to each other. So nothing earth-shatteringly complicated. Good luck.